Namaste children. Till now we have seen the modes of heat transfer, that is conduction, convection and radiation. In the process of radiation, heat is transferred from a hotter body to a colder body without heating the medium. So we receive the sun's energy by radiation. Another interesting fact about radiation is that the amount of heat radiation absorbed by a body depends upon the color of the body. Dark and black colored objects are better heat absorbers than light color objects. So here is the activity which is shown on the slide, the dark colored surfaces and colored surfaces. Dark colored surfaces absorb more heat than light colored surfaces. Now take two cans of same size, paint the outer surface of one can with black and the other one with white. Pour equal amounts of water in each and leave them in the sunlight for about 1 hour. Measure the temperature of the water in both the cans. The water in the black can is warmer than the water in the white can. Now, by this activity, we can say that dark colors absorb more heat rather than the light color. The dark color surfaces radiate heat more than the light color surfaces. Now, same activity you have to repeat by pouring equal amount of hot water of the same temperature, 60 degrees centigrade, and leave them in a room or a shade for 10 to 15 minutes and measure the temperature of the water in both the cans. The water in the black can is cooler than the water in the white can. That means the reading in the black can of water will be less than the water which is present in the white can will be, the temperature will be more. This activity proves that dark colored surfaces radiate more heat. By these two activities, we can conclude that dark objects or surfaces absorb more heat and radiate more heat than the light colored surfaces. Now, the kinds of clothes we wear in summer and winter. Basing on the above activities, since we know that dark colored surfaces absorb more heat than the light colored surfaces, dark colored surfaces radiate more heat than the light colored surfaces. We wear dark colored clothes in winter because it absorbs more heat and keep us warm. Whereas we wear light colored clothes in summer because it reflects most of the heat and keeps us cool. So we wear woolen clothes in winter because wool is a poor conductor of heat and the air in between the wool fibers prevents loss of heat from our body, so we feel warm. Now this slides shows all the three modes of transfer of heat in these pictures. See the heat by convection, conduction and radiation. The second picture also, radiation is sideways and conduction towards the handle and convection in the can. Now, what is wind? Wind is the horizontal movement of the air from an area of high pressure to lower pressure. There is uneven heating of earth is the horizontal movement of air from an area of high pressure to lower pressure. There is uneven heating of earth that results in global wind pattern. Now, two types of winds. Those are local winds and global winds. Local winds are the winds that blow over short distances, whereas global winds are the winds that blow steadily from specific directions over long distances. Now, wind is caused due to the difference in temperature and due to the differences in pressure. Due to the difference in temperature, the warm air rises. Warm air makes the molecules move faster and spread out. This makes the air less dense. So less dense air is light and will rise up. Differences in temperature. Cold air sinks. Cool air makes the molecules to move slower and group together. This makes the air more denser, so more dense air will sink. Now, differences in the pressure. Rising air creates low pressure. If air is lifted up, that means there is less air pushing down on earth. Sinking air creates high pressure. So if air is sinking, the air is pushing down on the surface of the earth with a high amount of pressure. Now, how all the three modes of heat transfer will be seen in day-to-day applications, that is in thermos flask. In thermos flask, how? If you are keeping the hot water till 2 days or 48 hours or 24 hours will be like that only, because it undergoes all the three processes, that is conduction, convection and radiation. How is it possible? Now, coming to the day-to-day applications, thermos flask undergoes all the three modes of heat transfer, that is conduction, convection and radiation. So, a thermos flask sometime or other used to keep hot liquids hot and cold liquids cold for a long period of time. Coming to the construction of a flask, a thermos flask is a double-walled glass vessel. The outer surface of the inner wall and the inner surface of its outer wall are silvered. The air between the walls is pumped out to create vacuum. The walls are sealed at the top and the flask is placed on a cork in a metal container. How does it prevent heat loss? The thermos flask is able to maintain the temperature of hot and cold liquids by limiting conduction or convection. There is vacuum between the walls and both these methods required a medium. Secondly, the glass, air, cork, all are poor conductors of heat. In the second one, the silvering of outer surface of inner bottle reduces any heat radiation. The silvering of inner walls of outer bottle reflects back most of heat incident towards it. So thermos flask is made in such a way that the heat transfer of heat is minimized through all the three modes of heat transfer, that is conduction, convection and radiation. See here, this vacuum prevents conduction and convection, since there is no medium. They need a medium to travel. Then silver coating helps in radiating as well as reflecting, and metals are good conductors of heat, but the glass casing, rubber cork, these are working as uh, insulators. So it's able to undergo the three processes and keeps the hot liquid as hot or cold liquids as cold when it is placed inside the thermos flask.